Hello everyone! Today we are going to be talking about decision matrices. So basically, this is just a tool to help us make tough design decisions. And it helps us use the objectives that we've already worked through to help us make that decision. Now, one reason this is a good way to kind of start your decision-making process is because it takes some of the feelings out of it. And rather than just going on which one you kind of think is going to be the best, it makes you think about why each of these things might have advantages and disadvantages. So the first thing you're going to want to do is make a ranked list of your objectives. So for me, I'm again doing that kind of like better than a broom thing, and my objectives ranked by importance are be cleaner than a broom, quick to clean a room, and I'm kind of trying to shorten these a little bit just because it's long to write. So easy to use and inexpensive. Now we want to rank these and because we're going to be using them a little bit later. Let me zoom in a little bit for you guys. Hopefully that's a little more legible. I'll try to write a little neater as well. Alright, so the next step is to take some design ideas. In this case, I'm going to take my move around the room design ideas. You might hear me call these design alternatives, right, because they're different alternatives for design. And I'm going to just list those down. So I have 2 wheels, and a caster, I have 4 wheels, I have treads, I have balls, so like a series of balls on the bottom, and I have a quadcopter, and a maglev. Now this is the part where we start to get a little bit more real. So in my last video I told you get really creative, throw out crazy ideas, see what happens. In this step, we're going to take our constraints and use them to cross out ideas that just don't fit what we're actually doing. We want to get those out there initially so that we can use them to our advantage, get our creativity going, but at this point we're trying to narrow our space back down. So in this case, I'm going to cross out quadcopter because it doesn't meet my design constraint of being able to fit under furniture, or at least not very easily. And I imagine I might run into some issues of it, even if it just like hits the bottom of a couch or something, it might get off balance and have issues. And I'm crossing out maglev because it would require additional things to be installed in the house. Now as you're doing this, you might realize that you have more constraints than you thought. Because I had the constraint about not fitting under furniture, but in my last video I didn't say anything about not having to install anything additional in the house. And so I actually found a new constraint during this process. Okay, so now we have our list of objectives and we have our list of design alternatives that fit our constraints. The next step is to actually start making our design matrix. Now this is going to have an x-axis and a y-axis. So on our x-axis, I want to have my objectives. So cleaner than broom, and then I'm just going to put quick, easy to use, inexpensive, really should have gone with cheap, so I could fit my total column. So these are going to be my columns. And then my rows are going to be my different designs. So 2 wheels and caster is going to go here. And then 4 wheels and treads and the ball idea. Okay. So this is now my design matrix. And what I want to do is rank my ideas. So what I want to say is an idea is a 3 if it totally meets the objective. Like, really does it super well. And then 2 is like, kind of meets the objective. Mostly meets the objective. Might have a couple small issues, but nothing major. And a 1 would be like, oh my gosh, no way. Doesn't meet the objective at all. Now, you can use a larger scale. You can use 1 to 5, you could use 1 to 10. In this case, we don't have that many design alternatives, and so I am going to be leaving it at 1 to 3. So remember, 3 is the best, and 1 is the worst in the way that I'm doing this. So first of all, I'm going to go through and I'm going to say, I don't think that any of the drive systems are going to have an impact on how clean the room gets. Because that's not the part that's actually doing the cleaning. Now, it might have some small effect in terms of, like, maybe you can't get into a corner as well with certain drive systems, but in this case, I'm actually going to ignore cleaner than a room because I will say it's negligible. It's not that important. You might have something like that, and that's an okay thing to do. Now, the next one is quick. So how fast this thing will clean the room. Now, I am basing these rankings on agility. So how easy it is for this drive system to get around complex shapes like a cat tree or a couch or a desk. And I would say that 2 wheels and a caster and the ball design are the most nimble and easy to move around. So those are going to get a 3. And I'm going to say that the treads are pretty good. Or sorry, the 4 wheels are pretty good. They'll be able to drive around, but they won't be super wonderful. And the treads have a hard time turning. So I'm going to leave those with a 1. In terms of easy to use, I am going to rank this on number of likely issues. So things that might break easily, things that might get stuck on things, those are going to affect ease of use. And so I would say that caster wheels and the 4 wheels idea, like, those are pretty simple ideas. That kind of drive system is really common, and it's pretty reliable, and probably not going to have that many issues. Whereas, treads as well. But the ball system, it's got a lot of moving parts, it's kind of tricky, it's kind of weird, and so I'm going to actually give that one a 1. Now, in terms of expense, I am ranking based on expense, thinking about how many different parts there are and how complex the system is. So 2 wheels and a caster, great. That only has, like, it's got 2 motors for the wheels, and then there's only 1 caster, there's not even 2 wheels. I'm going to say that the 4 wheels is 2. It has slightly more moving parts than my 2 wheels and a caster. And then treads and balls, I'm going to say, are slightly more complex. The treads, you would need to have some kind of gearing system. In the balls, you would have to have some kind of very interesting drive system. Okay, so now these are all ranked, which is great. And so what I'm going to do is I'm going to write up a total. Highest score is the design that meets my objectives the best. So this one is 8, this one is 6, this one 2, 3, 4, and this one is a 5. So we can see that the 2 wheels and the caster has the highest score by a pretty fair margin. And then the 4 wheels is in 2nd place, the balls is in 3rd, and the treads are in last, which is great. So we have a beginning of our design matrix. But one thing that we didn't take into account is being inexpensive just as important as being quick? Now, in this example, what we're going to do is we're going to say that we're going to weight these values, which basically means we're going to take each score and multiply it by something. The more important something is, the more we're going to multiply it. So we're going to say that being quick, we're going to weight 3 times. So we're going to make it 3 times as important. Easy to use, we're going to make it 2 times. And inexpensive, we're just going to do it 1 time. Okay, so now we're going to add kind of like a second score column for our weighted totals to see how this changes things. These are all going to be multiplied by 3. These are going to be multiplied by 2. and those can be multiplied by 1, so nothing has to happen to them. When we add that all up, we are going to get some new numbers. So it will be 16, 12, 8, and 12. So if we make quit being fast very important, and inexpensive much less important, with easy to use kind of in the middle, we see that our winner doesn't change. Two Wheels and a Caster is still the winner based on what we put down. But what has changed is that the balls and the four-wheel design have actually become equal. Because the weighting basically evened out the places where the balls were weaker before. So the weighting worked to the ball design's advantage. Now, if you've done all of this for your matrix and you're like, okay, but this thing like won Two Wheels and a Caster and I think that it's horrible for some reason, then you might want to consider, is there a constraint or an objective that's missing? And if not, then you might want to consider that maybe you need to keep your mind a little bit more open and there is a design that would work better than you thought it was going to. Now, a design matrix isn't the end-all be-all. If there's a design in here that doesn't do super great and you still really, really think that it would be the best design, just because it came out not high on the design matrix doesn't mean that you can't use it. It just means that there's something to really think about there. This is a place to kind of start your decision making, but it doesn't have to be the place that you stop. So go ahead, try this out for yourself. You're going to need one of these for each of your functions. You can also do it in one giant table, but just put a little label, so that you can see kind of where each function is. So I could just start the next function right here and then keep going across. Let me know if you have any questions, and I will see you all on Friday. Bye!